Okay, I'd like to finish up section 4.1 now. We're talking about maxes and mins. And in the last video, I kind of ended with the topic of a critical number. I mentioned that a critical number is going to be really important for the chapter. Nearly all the things that we'll be doing in the chapter are going to be, at some point, we'll need to calculate the critical numbers. Okay. Now, a critical number of a function is a number that is in the domain such that f prime of that number is 0 or f prime of that number does not exist. Okay, and we looked at one example of that. Now, we talked about absolute extrema. An absolute max is the absolute highest point on a graph, and an absolute min is the absolute lowest point on the graph. We also talked about local extrema, right? Just the highest or lowest point in the neighborhood. That was in the last video there. To find the absolute min and absolute max on a closed interval AB for a continuous function f, follow the list of 3 steps here. So step 1, you're going to find the values of f at the critical numbers of f in the open interval AB. Step 2, you're going to plug in the endpoints into the function, so find f of a and f of b. And then step 3, the largest of these values in steps 1 and 2 is the absolute max, and the smallest of these values is the absolute min. Okay? So let's take a look at some examples of where we're doing that. In these examples, I would like us to find the absolute max and absolute min for the following functions here. So here's my first one. F of x is 2x cubed plus 3x squared minus 36x minus 16. I want to know the absolute max and absolute min on the interval -1/2 to 4. Okay, now that's a closed interval. I've got a continuous function. Polynomials are continuous everywhere. And so by the extreme value theorem, I know I'm guaranteed to have both an absolute max and an absolute min on the closed interval. All right, so I'd like to know those in this problem. Well, let me follow the list of 3 steps that were there on the previous page. I need to first find my critical values. So let's calculate f prime of x. That would be 6x squared plus 6x minus 36. And I'm going to set that equal to 0 since I'm interested in the numbers that are going to return 0 from the derivative. You can divide by 6 on both sides to make the numbers a bit nicer when it comes to factoring. And the left side will factor nicely here in this problem. X plus 3 times x minus 2 is how that factors. And so when you set the factors equal to 0, you're going to have x equal -3 or x equal 2. All right, now I'm going to find the values of f at the critical numbers, and I'm also going to find the values at the endpoints of the interval. So my critical numbers are -3 and 2. The endpoints of the interval are where x is -1/2 and x is 4. Okay, so I've got to plug in all 4 of those values into the function, and I want to see what has the highest output and what has the lowest output. Okay, well, if I plug -3 into f of x, -3 cubed times 2 plus 3 times -3 squared minus 36 times -3 minus 16, I was getting 65 from that. Okay, and if I plug in 2 into the function, I was getting -60 when I plug in 2. All right, now plug in the endpoints on this interval here. So when I plug -1/2 into the function, I was getting 5/2 as the output. And then when I plug 4 into the function, I was getting 16 as the output. All right, now pay attention to the interval that is given to you. I only care about the highest and lowest values on the interval -1/2 to 4. -3 is not in that interval. So this calculation here was actually not necessary. Okay, and I wouldn't give that as an answer because that's not, -3 is not in the interval that I'm working on. So it looks like out of the 3 remaining calculations, 16 was the largest output. So that means I'm going to have an absolute max at the point 416. Negative 60 was the smallest output. So that means I'm going to have an absolute min at the point 2, negative 60. Now notice that if I was not paying attention to my interval here, I would have had a wrong answer if I would have said the absolute max is located at negative 365. Okay, some students will do that because they're not paying attention to the interval. So be sure that you're aware of the conditions on x. Okay, and it'll sometimes come up where, in the calculation you didn't actually need those numbers because they're outside of the boundaries there. Now we're going to do a lot of things with curve sketching, You'll see that kind of midway through the chapter in section 4.5, they've got a curve sketching section, that's what they call it. And in that section, we're going to basically take everything that you've learned from algebra and trig, along with everything that you will be learning here in chapter 4 with calculus and the calculus stuff that we've talked about before this, and we're going to sketch pretty detailed graphs of functions. Okay. So a lot of chapter 4 has to do with graphing, okay, and how the derivative plays a role in sketching a graph, and how the second derivative also plays a role in that. We'll talk about that. So if I were to sketch a graph of f of x on this interval, okay, I've already got 4 points that I can work with here, okay, so I've plotted. Here's negative 365 now, and I actually don't want that on my interval, right? So let me comment on that once I got the rest of these plotted. F of 2 is negative 60. Okay, so here's 2, negative 60. The scaling is not the same on both the axes. That's fine. Okay. F of negative 1 equal 5 halves. So here's negative 1 half 5 halves, this point right here. And then f of 4 equals 16. Here's 4, 16. Okay, and also if I plug in 0, I get negative 16. That'd be the y-intercept on the graph. Okay, so I've got, a few points here. Now I don't want this entire graph to be represented, right, because x is ranging from negative 1 half to 4. So you can see that if you're going from negative 1 half to 4, the highest point would be this point here, 416. The lowest point would be this point here, 2, negative 60. Okay, here's another example. I want us to find the absolute max and absolute min for the function f of x, which is given on the closed interval negative 1 to 3. Okay, now f of x is continuous, and I'm working on a closed interval, so by the extreme value theorem, I'm guaranteed to have both an absolute max and an absolute min on that closed interval there. So let's go ahead and find those. Well, I need to first get my critical numbers by calculating f prime of x. Derivative of 2x is 2, minus the derivative of 3x to the 2/3, so you use the power rule. When you bring down the 2/3, the 3's would cancel, so that'll leave you with 2x to the negative 1/3 when you reduce the power by 1. Okay, 2x to the negative 1/3, that's the same as 2 over x to the 1/3, and you can get a single fraction out of this expression. 2x to the 1/3 minus 2 all over x to the 1/3 is my single fraction then. And if I set that equal to 0, multiply both sides by x to the 1/3, and then if you add 2 and divide by 2, x to the 1/3 equal 1 means that x would be 1. Okay, so 1 is a critical number. Now, I mentioned make sure that you get all of the critical numbers. Some students won't do that, okay? And that can be a problem, okay? So a critical number, again, is a number that is in the domain of the function such that f prime of that number is 0 or f prime of that number does not exist. Don't forget about that. So 0 is a problem here for f prime of x, right? I know I can't divide by 0. Therefore, 0 is a critical number. Now that's important in this problem. So if I were to plug in my critical numbers now along with the two endpoints, I'm going to do that and see what output is the biggest and what output is the smallest. Well, f of 1 is 2 minus 3 is negative 1. Okay, f of 0 is 0. And now plug in the endpoints here on the interval. F of negative 1, so negative 2, and then negative 1 to the 2/3 power, negative 1 to the 1/3 would be negative 1. Square that, you get 1. So we're looking at negative 2 minus 3 is negative 5 is the output. And then if you plug in 3 into the function, you'd need a calculator for that. I was getting roughly negative 0.24 if you go near as 2 digits. The largest output is 0. So 0, 0 would be my absolute max. Now, if I didn't recognize 0 as a critical number, I would have a wrong answer, right? So that's what I've, make sure that you get all the critical numbers. The lowest output is a negative 5, so negative 1, negative 5 would be my absolute min then on this graph. All right, and I've sketched the curve on the interval that was given here. So 1, negative 1 is right here, 0, 0. Okay, negative 1, negative 5, and then 3, negative 0.24. I plotted those points and drawn this curve. There's going to be a sharp turn at 0, 0. How do I know that? Well, it's because you're not differentiable at 0, right? 0 is a problem for the derivative. 0 is not a problem for the original function, right? I can plug in 0 into f of x, there's no problem with that, but I know I can't divide by 0 with the derivative, so I'm not differentiable at 0. Well, what does that mean? It means I got a sharp turn. Okay, so when I calculate this point here, that's one of the things that I'd want to recognize. If I do sketch a graph, there's going to be a sharp turn at that point. That's okay, I can still call this an absolute max, right? The absolute min then is, you can see, negative 1, negative 5. Now this may look like, if you're between negative 1 and 0, this may look like I've drawn a line. In fact, it's not a line. If you were to zoom out a ton on this curve, in quadrant 3, there is going to be a curved thing going on here, okay? So just take note of that. All right, here's, I got one more example for this section. So how about f of x equal 2 sine x minus cosine of 2x? We'll look at a trig thing here for x ranging from 0 to 2 pi. Okay, now I've got a continuous function, x can be anything, and the interval is closed here, so I will be guaranteed to have both an absolute max and an absolute min on this interval. Let's go ahead and find those points. So I need to get my critical numbers. F prime of x would be 2 cosine x, and then here's a chain rule. It's going to be minus negative sine of 2x times the derivative of 2x is 2. Minus a negative means plus. And you can divide both sides by 2. Sine of 2x, you'd want to use a trig identity. There's a double angle formula that says sine of 2x is 2 cosine x sine x. Now that's not an identity that you need to know at this point, but it is an identity that you will need to know in Calc 2. Okay, you'll be using that identity here and there for some things that are in Chapter 7 once you get into Calc 2. So anyway, I've used that identity, and the nice thing about using that identity is because I don't like the double angle and then single angle. Like I'd want everything to be in terms of single angles. Okay, and I've got that. Cosine x is in common to these two terms. You can factor that out. 1 plus 2 sine x would be my leftover. And so now you can set the factors equal to 0. Cosine x equals 0. Or 1 plus 2 sine x equals 0. Subtract 1 and divide by 2. That means that sine x equal negative 1/2. All right, when does cosine x equal 0 on the interval 0 to 2 pi? Well, cosine of pi over 2 is 0. Cosine of 3 pi over 2 is 0. Cosine of 5 pi over 2 is 0, right? But now I'm outside my interval. So these would be the only two numbers that would return 0. How about sine x equal negative 1/2? Well, sine x is where I take opposite over hypotenuse. So the opposite side in this triangle would be -1. The hypotenuse would be 2. Okay, if you were to draw a triangle in quadrant 3, where the opposite side is -1 and the hypotenuse is 2, the adjacent side would be -√3. Okay, that'd be a 30, 60, 90 right triangle. And the angle that you would be talking about there is 7 pi over 6. Now that triangle that is in quadrant 3, if you were to flip it over into quadrant 4, that would affect the adjacent side, and that'd be a positive √3, which we don't care about for sine x, right? Sine x is opposite over hypotenuse. We don't care about the adjacent side. So the opposite side would still be -1. The hypotenuse would still be 2. Okay, the angle that you would be describing there would be 11 pi over 6. Now, if I were to draw that triangle in quadrants 1 or 2, then the opposite side would be +1, and I don't want that. I need the opposite side to be a -1. So these are going to be the only two angles for x, where sine x is -1/2. In all, I've got 4 critical numbers then. Okay, so I'm going to plug in those 4 numbers along with the 2 endpoints on this interval, and I'll see what output is the biggest and what output is the smallest. Okay, now, like we've been doing, make sure that you're giving exact values. We don't need a calculator for any of this. So if I were to plug in, I'll just start with the endpoints here. If I plug in 0 into the function, sine of 0 is 0, cosine of 0 is 1. 0 minus 1 is -1. Okay, how about if I plug in 2 pi? Sine of 2 pi is 0, cosine of 4 pi would be 1. 0 minus 1 is -1. Okay, now how about with the critical numbers? So if I plug in pi over 2 into the function, sine pi over 2 is 1. Cosine of 2 times pi over 2, the 2's cancel. Cosine pi is -1. Okay, 2 minus -1 is 3. How about if I plug in 3 pi over 2 into the function? Sine of 3 pi over 2 is -1. Cosine of 2 times 3 pi over 2, the 2's cancel. Cosine of 3 pi would be the same as cosine of pi, that's -1. So I'm getting, let's see here, -2 minus -1, that'd be -2 plus 1 is -1. How about if I plug in 7 pi over 6? Sine of 7 pi over 6 is -1/2, since that was a solution to this equation, right? Times 2 is -1. Okay, and then cosine of 2 times 7 pi over 6, well, that'd be cosine of 7 pi over 3. 7 pi over 3 would be the same radial line as pi over 3. So, and cosine of pi over 3, that would be 1/2. Therefore, cosine of 7 pi over 3 would also be 1/2. Okay, so I've got 2 minus 1, or where are we at here? -1/2 times 2 is -1, and then minus 1/2 gives me -3/2. And then how about 11 pi over 6? So sine of 11 pi over 6, that's -1/2, times 2 is -1. And then cosine of 2 times 11 pi over 6, that'd be the same as cosine of 11 pi over 3. Okay, 11 pi over 3. Well, let's see here. So if we have, that would be the same thing as negative pi over 3. Or that would also be the same thing as 5 pi over 3. Cosine of pi over 3 is 1/2. If you flip that triangle over into quadrant 1, well, that's going to affect the opposite side. So cosine of 5 pi over 3 would still be 1/2. Cosine of 11 pi over 3 would be the same radial line as 5 pi over 3. So cosine of 11 pi over 3 would also be 1/2. Okay. -1 minus 1/2 is -3/2. Now, you can see then from these calculations that looks like the point pi over 2, 3 is going to be the absolute max, since 3 was the biggest value that came out of this. And you're going to have two absolute mins. So let's see, 7 pi over 6, negative 3 halves, and then 11 pi over 6, negative 3 halves would be my two absolute lowest points then on the curve. And so I've drawn the curve here. I plotted these points. Okay, here's 0, negative 1. Here's 2 pi, negative 1. Pi over 2, 3. 3 pi over 2, negative 1. And then 7 pi over 6, that's just to the right of pi. I'm coming down to a height of negative 3 halves. And then 11 pi over 6, that is just before 2 pi. I'm also coming down to a height of negative 3 halves. Now I've got a max at this point, so I know there's a hill on the graph. I've got a min at these 2 points, so I know there's valleys. Okay, and I can go ahead and draw the curve then on the interval that's given. Okay, so we're now done with section 4.1. And be sure to look at the problems there that are on page 283 for me, the odd number problems.